In today's lesson, we're going to extend our learning by applying the same strategies that we use to solve simple inequalities with compound inequalities. In today's objective, we're going to solve and graph compound inequalities. The word compound suggests that we're working with more than one inequality within the same expression. Let's go ahead and review some of the things that we already know about solving inequalities. We can solve inequalities by applying the inverse operations, or in some cases we might need to group. But in this example, we have 72 is less than or equal to 8n. This is a one-step inequality. We know that we're multiplying our variable by an 8, so the inverse operation would be to divide both sides by 8. And we simply solve this to be 9 is less than or equal to n. Or, similarly, n is greater than or equal to 9. And we also want to review when do we use an exclusive open circle and an inclusive closed circle. So given that we have the inequality k is greater than 9, on our number line we want to plot the number 9. It is exclusive because it does not contain the number 9. It's everything that's greater than 9. We want to do an open circle. And we know that greater than means that we're going to shade all values to the right. Similarly, we can apply the same thinking in graphing our inequality on a number line, except this time we want to be inclusive. So when we plot our value of 6 on the number line, we need a closed circle rather than an open circle. A closed circle means that we want to include the value of 6 or whatever value it's being equal to. So we have less than or equal to 6. That means we're going to shade to the left because all those values to the left are going to be smaller than 6. Now that we have this down, we're going to move on to today's new idea. What do we do when we have an expression, and in this case called an AND statement? An AND statement means that we have one variable expression, but it has two different restrictions. So if you see that there is a variable expression contained within the variable inequality, we're going to break it up into two separate inequalities. So we're going to rewrite this as negative 16 is less than or equal to 2k. It's an AND statement. 2k is less than or equal to negative 10. So we can solve each of these independently by applying inverse operations. So let's go ahead and divide both sides by 2. So we have negative 8 is less than or equal to k. And we're doing the same thing over here. Divide both sides by 2, we get k is less than or equal to negative 5. So the only thing that's different about compound inequality is it's going to look different when we graph it on a number line. So let's go ahead and visualize that number line. We know that negative 5, let's go ahead and plot our negative 5, both are constants, is somewhere over here. We know that negative 8 is less than negative 5, so we know it's somewhere to the left of that negative 5, so I'm going to put negative 8 to the left. And we know that we have two inequalities. We have k is greater than or equal to negative 8. It is a closed circle because it has that expression. And we want to shade all the way to the right because we're moving to greater than. But we don't want to go all the way because there's another inequality to consider. This here says that k is less than or equal to negative 5. Again, since we have that equal to expression, we need a closed circle. And in this case, we want to highlight all the values that are to the left of that negative 5 because it says less than. So in this inequality, we are bounded by a closed circle on these 2 points and all the values that are in between. That is an AND statement. There's another type of inequality called an OR statements. OR statements are already separated by into two inequalities. We just need to solve them independently. So we're going to go ahead and add 2 to both sides because we originally subtracted. So we end up with c is less than or equal to 3. And this one we have subtract 7 on both sides. So we have c is greater than or equal to 11. So let's go ahead and pop up that number line, and we're now going to plot it. We know that 3 is, let's say we plot 3 is over here. We know that 11 is bigger than 3, so we're going to plot it somewhere to the right of that number. And we're going to take each inequality one at a time. We have c is less than or equal to 3. We know it's a closed circle because of that equal to expression. It's less than 3, so we need to shade everything to the left. Now we have c is also greater than or equal to 11, so we have a closed circle once again. But since c is greater than 11, we want to shade all the values to the right. Now, the difference between the AND statement and the OR statement is you'll notice back in our AND statement, there were 2 points that have all values in between, whereas in OR statement, we have 2 dots, but the arrows, or what we shade for values, go in opposite directions. So OR statements would always be divergent, which means the arrows are going to go away from each other. And AND statements are going to be convergent, which means that the shaded parts will going to overlap. So let's go ahead and look at an example that we can work together. So in this problem that we're going to do together, we have an example of an OR statement. We know it's an OR statement because we have 2 separate inequalities that are independent of each other. And we know it's an OR statement because we have these 2 variables that are the same in these 2 inequalities. So let's go ahead and solve by applying the inverse. So we need to multiply both sides by 2 because we started off by dividing. And we're going to do the same thing with multiplying both sides by 5. And we know that if the same number exists in the numerator and the denominator, they just reduce to 1 by the identity property. So if we multiply that with f, we're going to have 1 times f is less than 14. Or f is greater than or equal to 20. So let's go ahead and bring up that number line, and let's go ahead and get started to graph. So we'll notice that our inequalities, we were working with inequalities that had either greater than paired up with less than, or we had greater than or equal to paired up with less than or equal to, which means we either had both closed circles or both open circles. In this example, we are noticing that we're probably going to end up with an open circle and then a closed circle. So let's go ahead and plot our values of 14 and 20. Since we have a less than 14, there's no inclusive value, so that's an open circle, and less than means that we shade to the left. We have f is greater than or equal to, that means we have a closed circle with values that are greater than 20, which means we need to shade to the right. So we have an open circle here and a closed circle over here. Notice again it's convergent, which means the 2 arrows are pointing in opposite directions. That is an OR statement. Now it's your turn to go ahead and try to solve this problem. I'm going to give you the hint that this is an AND statement, so in order to solve an AND statement, we need to go ahead and break it up into 2 separate inequalities. So here is inequality number 1. Negative 11 is less than s plus 8. And then we have another inequality, which is s plus 8 is less than or equal to negative 3. Once we break them up into 2 separate inequalities, we can solve and then graph. And then, since we're only working with 1-step compound inequalities, why don't you give a go at two-step compound inequalities. Let's see if you can get the final correct answer.